Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Hello everyone, and welcome back to our course. In this lecture, we are starting our project of building a top-down game from scratch in Unreal with C++. I have launched the Unreal 5 engine here and gone to the Games category. Here, we're going to select our project template to be blank because we're creating the project from scratch. We are going to be creating a clean, empty project with no code. The project defaults, we are going to choose C++ as the scripting type of the game. The target platform can be desktop. That can be also changed later if you want to build for mobile. Quality preset will be maximum. We can include starter content, so we'll get some meshes and materials that we can use, and we don't need real-time ray tracing. Next, choose a project location in the bottom left and a project name on the bottom right. I'm going to call this our top-down game. All right, and next, let's press create, and that is going to launch the project in the Unreal Editor. And here is our project. Visual Studio will also launch because we made a C++ project. So we have a bunch of C++ classes that we can make. Just one is created by default. In the bottom right, we're going to update the project, and here we can look at all the project contents. I've zoomed in my text size here, so that's why my icons look a lot bigger, and then my play button is on the right-hand side instead of being in the center. Okay, we can also delete some of the default objects from the screen. These were included because we selected to use starter content. Some starter content are these chairs, the table, decorations, but we can just delete those. Let's also delete one of the floors, and we'll just work with this one floor. I'm going to increase this floor's size by selecting the scale tool and then dragging out one of the ends of the arrow. We want to have a large floor because we want to have a large space where our player can roam around. You can also change the size of the floor by going to the details window. And here you can change the scale of the floor, for example, to 100 by 100. That will be a lot larger. This 2 here, that is the height of the floor, so we don't need to change that. Okay, then we can move the floor around by using our arrow tools, our selecting and translating tool. Okay, so here we go. We have our floor. If you save this and press play at this point, you'll be able to see the camera is rendering the floor, and we can look around. We can also move around. Okay, so this is the default view. Coming up next, we're going to create our own camera to make this game a top-down game. You could leave it 3D here, but I'm going to show you how you can create your own camera, so that way you can have whatever viewpoint you want. So join me in the next lecture. Hello everyone, and welcome back to our course. In the previous lecture, we created our project and we also changed our floor size. Coming up in this lecture, we're going to now build our own camera. So instead of being a first-person game, we're going to make a top-down game with our own camera. All right, so let's go into our game, and in the top left-hand corner, we're going to select Create. Here, we need to find a camera. So we can go to all classes and select the camera here, just the regular camera object. It will be called camera actor when it gets added to your world outline. Okay, so there we go. Now we have our camera, and we can move this and as well rotate it to then have it be top down. So for example, I could take that camera actor and I can select the rotation tool. Okay, then let me also just zoom in on it by selecting it and pressing F. Okay, so there is that camera right here. Then I can drag this to the side and move around in order to see it. So there is this camera that I've added. Now, let's say we rotate it down on one of these axes. Well, you're going to be able to see the change reflected in this little camera preview. Okay, so here I'm rotating my camera down. You can see the camera is now facing the ground directly. And now we have a top-down camera. You can also use the movement tool and move that camera up. Okay, and notice you won't see much change just because the floor is really big, but you can see some change in the floor. So as we are moving up or down, you can see the floor reflected. So you can move this as high as you want to show as much of the floor as you want. It doesn't matter at this point because what we're going to have to do is have the camera follow our player around. So it doesn't really matter how high up it is. The higher up it is, the farther away it will be from our player. And we can adjust this at any time. We can also change the floor because now that we have our view, we can change our floor's material. So let's just click on the floor and then go into its details. And here under the details, we have transform. Let me just drag this up. We also have static mesh and then material. So we have one material on this floor, the brushed nickel, but we could change this to any material we want. Okay, so here you can scroll through. Because we included starter content, we actually have quite a few materials. For example, we have grass. If we double click on that, we now have grass in our world. So let me just select my camera, and now you can see our player is playing on grass. You could also just choose a solid color for your floor as well. So let me select my floor and then go to materials. If you want to select a solid color, you can create a new asset or a new material. And then let's just right click and create a new folder that we'll call materials. And we can enter that and we can create a ground material and we can just have a solid green color. So let me double click on this ground material to open up its blueprint. Here we have to set its base color property. So I can drag a node off of base color, and then here I'm going to choose a constant 3 vector, which means 3 values, because a color is represented as a series of red, green, and blue values. Double click on that square in order to open up the color picker for this material, and then let's choose a green color. Make sure you drag up here the value and the saturation. Okay, and then you can double click here to see a preview. If you click here, you'll be able to see this update. Sometimes it takes a while to update. Okay, so there is our color now. You can keep changing it until you have the green that you like. Typically, you don't want to have too bright of a color. You want to be somewhere in the middle, because if it's too bright, it will look tacky and it'll be hard on the eyes. It can take a moment for the material to update in the preview here, but to update that, just save the material. Okay, so now we can go back to our game and look at that. We can see we have a green floor. If I click on my camera now, I'll see that green bottom floor here. Okay, but if we press play, we'll notice that our camera is actually still in this first person view, because we have to specify what we want the camera to be, which camera we actually want to use. What we're going to do is change the blueprint of this camera to be saying that we want our camera to be the default camera. So select the camera actor object here, then go to blueprints above the viewport and select open level blueprint. Then there we go, we have our blueprint event graph open for the level minimum default. All right, here we need to force Unreal to select our custom camera as its main camera. All right, so let's go ahead and bring in the function that we need. I'm going to right click here in the event graph and I'm going to search for set view target with blend. Okay, so let me just set view target. If you don't actually see it coming up, just remove this context sensitive, which will filter the list to be what it recommends for the current context. But if you just unselect that, then you will have that option appear, the function for set view target with blend. If we want this function to actually be called, we have to connect it to some event. So I'm going to right click again in the event graph and search for the begin play event. This will run when the game begins playing. And if I connect these two, then now as soon as the game begins playing, we'll call this function. Next up, what is the target of the set view target with blend? All right, well, the target is going to be our player controller. So we're going to right click in the event graph again, and we're going to search for get player controller. Right, and let's see, I'm just going to scroll down until I get to that one. This will give us the player controller, and the return value is the target for set view target. Next, our new view target is our new camera. So we're going to right click in our event graph, and this time make sure you turn context sensitive back on. That way you can see this option, create a reference to camera actor. You can also search for that here. So grab that, and then you'll have a reference to that camera, which you can drag to fill in as the new view target. Okay, and that is all we need in order to change which camera is the main camera. So let's compile and save, and then press play again. And look at that. Now we have this top-down camera view. If we click in the viewport, then we can use the WASD keys or the arrow keys to move around this player. And that is just the default player that was created when we created our project. To remove sound from the game, we can go into our world outliner and we can remove this audio object. So let's just delete that. And now let's see if I press play again. Okay, this time we don't have any sound. All right, so that's all we have to do in order to remove the sound effects. And that is how you can build your own custom camera for your game. Join me coming up in our next lecture. We're going to build our custom player to replace that default player that we just saw. Hello everyone, and welcome back to our course. In this section, we're going to build out our custom player, starting with, in this lecture, building out the class for our player. So let's go into our Unreal project, and inside of the content browser, let's go into our C++ classes folder. Here in our project folder, we're going to create a new C++ class to represent our custom player. So I'm going to press add, and I'm going to select new C++ class. The type here, it has to be something that can move around and receive input, so I'm going to choose a pawn. The name of this I'm going to call my character controller. It has to be a name that isn't used by another class. Then when you press create class, that's going to generate the header and C++ file for that class. So Visual Studio is going to launch, and you'll have to reload the game because there's now a new class added to it. So make sure that in your Visual Studio solution, you now have your character controller C++ file and your character controller header file. Then back in Unreal, you also have to make sure that those changes are reflected on the Unreal side. So you see, after a moment, I can now see my character controller C++ class on the Unreal side as well. If you don't see it, then close and reopen your project in Unreal. You can also, as well, go to your Visual Studio project and build it and compile it, and then you'll be able to see the C++ class in your Unreal project if it's not coming up automatically. All right, now that we have our class created, let's go ahead and open up that class in Visual Studio. Next, let's create our first fields for our character. We're going to do that inside of the header file first, which is where we declare all of our properties and our functions. I'm going to go into public here and declare some new properties and functions for my character. By default, we already have begin play and tick, as well as set up player input component. We have all this default code because we made this a pawn. Inside of the public category, let's go ahead and create our first property. We'll make it a U property and call it edit anywhere. We're making it edit anywhere so that way you could edit this property in Unreal without even having to compile this code. But that's only for this one property because it's edit anywhere. Next, let's make this a float that we can call speed, and we can set this to something like 10. So that is going to represent the speed of our character. Next, let's also make an F vector, which is a vector that is made up of 3 float values that to represent the X, Y, and Z. We're going to call this our current velocity because velocity is speed with a direction. Then let's declare functions. Let's declare move horizontally, which will take in an axis value. And let's declare move vertically, which will also take in an axis value. Okay, so that is going to allow us to use our input from our player in order to move the character. For example, our player could use the WASD keys or the arrow keys to move around the character. Next, let's go into the corresponding C++ file. Here we do have to give values to our properties if we haven't already, and we also have to initialize our functions. We have to give them a body, and all of that is done in the C++ file. So first off, we're going to enable our player to receive input. For that, we want to go into the constructor for our character, and I want to first set the property auto possess player, and I'm going to set that to equal e auto receive input player 0, which means that my main player is going to be this character now instead of any default Unreal player. Instead of having that default Unreal player receive the input, we're instead going to be using this character as the pawn that receives the input. Next, we're going to actually move our player. To do that, we are going to enter first our tick function, which is going to execute every frame, because our player could potentially move every frame, most likely. Here I'm going to add a check to see if the current velocity is not currently 0. So if current velocity dot is 0, and we're checking if that's false, which means that my character actually has velocity, so it has to move. What I'll do is I'm going to create a new location for my character. I'm going to create an f vector, which is a series of 3 values to represent the x, y, and z location. Then I can call this my new character position. I'm going to use the function get actor location to get the current location of this pawn. Then I'm going to add the speed of the character, which was 10, multiplied by its current velocity, and multiplied by delta time in order to ensure that it looks the same speed across all devices. Next, I have to call the function setActorLocation and pass in my new character position. Okay, and we want to actually bind this functionality to move x and y. Remember, we had these functions declared, move horizontally and move vertically. We need to bind them on the Unreal side, but let's get started in C++ first. All right, I need to enter this function setup player input component, which handles getting input from the player and therefore moving the character around based on that input. Here, we're going to grab the input component, and in this case, it's the player input component. And here, we're going to call bind axis and pass in a name such as move horizontally. Then we're passing in this character to move, and the callback, which we're going to do when that axis input is triggered, is we're going to enter the A character controller class, and we're going to call the function move horizontally. Now this binding, we actually have to set it up on the Unreal side, and we'll do that shortly. Next, we have to do the same for vertically, so let me just copy and paste this, but I'm going to replace move horizontally instead with move vertically. Okay, so now we have bound the 2 axes. We want to also implement move horizontally and move vertically inside of the C++ file, so I'm going to create a function void a character controller. That's the class that it comes from. And then we're going to create that move horizontally function. This takes then an axis value, which is how much to move by. And you'll see what that value is on the Unreal side momentarily. And when this function is triggered, we want to change the current velocity of our player only on the x-axis. To do that, we're going to use the fmath class and clamp, which means we're forcing it to be between a min and max inclusive. We're going to take the axis value and clamp it to be between -1 and +1. So those are the min and max. And we're multiplying that by 100 just so that we have more movement. Because if we just had 1 as our scale, that'd be way too slow. We want to do the same thing for moving vertically, so just copy and paste that and change move horizontally instead to move vertically. And make sure you change the X to a Y. All right, now we want to create the input bindings on the Unreal side. So let's open up our Unreal project. Here in the bottom right-hand corner, first press this icon to compile our C++ code. This is an alternative to using the Visual Studio debugger or launching your solution in debug mode, which would also compile the C++ code. With this option, you don't get to see your errors until you actually press play, usually unless there is an error during compilation. So if you are debugging, it's best to, instead of just hitting compile in Unreal, it's best to use the debugger button in Visual Studio in order to launch your project in debug mode. Just take note that any changes you make in debug mode are temporary, so you have to stop the debugging before you make a change. And that change will be temporary on the Visual Studio side and on the Unreal side if you're in debug mode. But you have two options. You can either compile the code via the debugger or via Unreal. Okay, so let's just go back to Unreal here and go back into our project. Next, we have to set up the input bindings on the Unreal side. So I'm going to go into our settings and go to project settings. Under engine here, I'm going to select the input category. Here, I'm going to select a new axis mapping, which means a continuous mapping, because whenever, for example, the W key is held, that means the player wants to move forward. It's not just one press of the W key to move forward a little bit each time, because that would be way too tiring on the player. For one-time presses, you can use action mappings, for example, for something like jumping. But for movement, that is going to be an axis mapping. Let's create a new axis mapping. So I'm going to press the plus button here and then expand that both times. This has to have the same name that we already specified, move horizontally. This has to be the exact same name because that is what the C++ code is looking for. Underneath that, we can choose a key that we want to use, and for moving horizontally, we can use either the arrow keys or the WASD keys. Let's use the WASD keys. Now for moving horizontally, that's just the A and the D keys. So select A, then we'll add another one, and this time we're going to select D. So let's go to the keyboard and find the D key. Now A is moving you left, D is moving you right. So the A should be -1 and the D should be +1. Next, we want to do the same for moving vertically. So I'm going to create a new axis mapping and call it move vertically. This has to be the same name that we called the binding in the C++ side. Then we're going to select a key from the keyboard. Let's use the W key. And as well, we're going to select the S key. Because players are familiar with the WASD keys or the arrow keys, so we won't have to teach them a whole new input system. W is moving you forward and S is moving you back, so S has to have a scale of -1. And this is that axis value we were talking about. It's from -1 or 1. All right, now we can go ahead and test this out. So let's go ahead and close this. And we have our character controller, which is going to be our character object. But if we want to actually test this, we have to actually give a visual to our player. So let's go ahead and drag this character controller into the game. And then in the details window, you can add to it a new object, such as, for example, a sphere. Okay, so now we can actually see that player. Next, I'm going to save the map and I'm going to press play. Let's go here and hit play to launch the game. And click inside the viewport to get control. And now you can use your arrow keys to move around. Okay, looks like currently our arrow keys are working in the wrong direction. So if I press W, I go left. If I press A, I go down. If I press S, I go left. If I press D, I go up. So this just means I have to rotate my camera. I'm going to press escape and take my camera and rotate it. So I'm going to use the rotation tool here. Let me just move over so I can see it. There we go. And I'm going to rotate the camera by 90 degrees. Okay, there we go. We can also move it so that way it's showing our actual player. Okay, there we go. Now if I press play, we can see this time if I use my WASD keys, I move up and down, but if I use my A and D keys, I'm moving left and right, but actually in the opposite direction. So this can often happen. I'm going to press escape and go back into my project settings and back into input and just reverse the A and D from -1 to 1 and from 1 to -1. That's totally fine. It can happen dependent on the way your camera is facing and how it's rotated. So you can change those axis values. And after that, you'll find that your arrow keys move as expected. Your WASD keys move as expected. And if you linked up your arrow keys, they would work as well. So I can use A to move left, D to move right, W to move up, and S to move down. And because it's an axis mapping, it's continuous. It's not like I have to press A 100 times just to move over. All right, and that is how we can build a custom player that can move around. Now, if we want our camera to follow the player, all we have to do is make the camera a child of the player. So in our world outliner, we can grab the camera and just drag it right on top of our character controller. And you'll see, look at that now, the camera actor is a child of the character controller. So if I press play this time, you'll see that our player appears to not move. But what's actually happening is they are moving. You can see them moving, and our camera is following them around. So if we had other objects around, that would be evident. For example, we could add here a basic shape like a cylinder. Okay, so I could just add a cylinder to the game and then move it to the side. And then you'll see that we are indeed moving around. So there is my cylinder. I want to put it close to my player. Then I'm just going to take my camera here, and I want to make sure that my camera is going to be positioning my character in the center. So I'm just going to take the camera and move it forward. Okay, so that way my character is going to be in the center here. So let me just grab that camera, okay, move it that way. Just rotate it until, not rotate, but move it until my player is in the center of the view. Because typically that is how the game goes. Your player should be in the center. Okay, so now let's press play. And our player is in the center. And if we click in the viewport, you can see we're moving around. And the camera is moving with us. They're moving as a unit. All right, and that is how you can set up controls for your player. Join me coming up next. We're going to continue building out our player. We can enable our player to attack enemies as well as collect food. And we'll continue this project in the next lecture. Hello everyone, and welcome back to our course. In this lecture, we are going to begin building out food for our game that the player can eat to then get bigger. So let's go ahead and get started. We're going to create a new C++ class for food. So let's go into our content browser and into our C++ classes folder. Here we're going to add a new C++ class, and we are going to have our parent type be an actor. Because food is not going to move, it's just going to be spawned in the world. So it can be the basic type, which is just an actor. I'm going to press next, then I'm going to call this food. And I'm going to select create class. That's going to launch Visual Studio with my C++ project. If the food class doesn't appear right away in your Visual Studio project, then just reopen the Visual Studio project manually. All right, and here we go. We now have food.c++ and food.header. All right, let's get started by creating a collision box around each food item. And we're going to do that with code. So once this loads up, I'm then going to pop open food.h and food.cpp. All right, let's get started inside of food.h, where we declare our properties and functions. We're going to get started by declaring a property for our collision box. And this can be public. We're going to create this U property and we'll make it edit anywhere, which means we could edit it in Unreal without even having to compile the code. This is going to be of type U-shape component, and it's going to be a pointer that we'll call a collision box. Next, let's initialize this property in the C++ file. Okay, we're going to be doing that inside of our food constructor. So before this line that enables tick to work, we're going to add our collision box, and we're going to initialize it, give it a value, by using create default sub object. It's going to be of type uBox component. That's how you can create a collision box. And here the text is going to be root. We're just adding it to the root of our class here. So it'll be added to the root of the object. Now, in order for the uBox component to work, we do have to include the class for it at the top of our file here. So after food.h, because that has to be first, we're going to add another include line for components/box component.h. Just make sure you have a hashtag there. That will enable the uBox component to work just after a moment here. Awesome. Okay, next up, let's go and create a visual for our coin. So I'm going to compile this code in Unreal. You could also compile it via Visual Studio, but just remember, any debug mode changes that you make, they will be temporary, so you have to hit stop after you've compiled. I can also just go to Unreal here and press the compile button in the bottom right. The downside is it's harder to see errors, but they still will show up. It's just less convenient to see them than in Visual Studio. All right, next, once this compiles, we're going to create a visual for our food. Okay, so let's go ahead and we're going to drag our C++ class for the food right onto the game. And you can actually see it has a box around it. That's because we gave it a box component in its root. So if you go to the details, you can see the collision box is the root object. Okay, that's this box that you can see in this thin yellow outline. We can add another component by pressing the add button here onto the food, and I'm going to add a sphere. I'm going to reduce the sphere's size, so let me select my scale tool and just bring that down because food should be smaller than my player. I'm also going to change its color. You could set your own custom material, which we learned how to do previously, or as well, you could just select one of these colors here. You have some oranges, some blues. They're not exactly made for the food, but you could still use them for a quick prototype. Okay, for example, you could select a green color or this teal. You want to make sure it can be seen on this green background. That's the only thing. Also, let's just drag up this food a little bit, okay, to make sure it's above the game. Okay, great, it is. Yeah, you just want to make sure that the food can actually be seen. So on the sphere, let's just choose a color that you can see. We have this red. Typically, red is for symbolizing danger, so you don't really want to use it for food. You could use orange or this blue there. That can be kind of seen. You want to have a good enough contrast. If the contrast isn't good enough, it's going to be frustrating for your players. Okay, that blue is fine. You can save and press play to see what that food looks like. Okay, it's kind of small. And there it is. Currently, it's just hovering above the ground, but you can move it anywhere you'd like. And it's not important exactly where it is because we're going to be setting the position of each food randomly via code anyway. Okay, so let's also delete this cylinder. We won't be needing that. Okay, there we go. So now we have our food object with a collision box around it. Coming up next, we need to enable our user to actually have something happen with this food, because currently you'll notice if I run into the food, well, currently it's a bit too high, but I can move it down. See what happens when I collide with it. So let me just grab that and drag it down so that it's just above the ground. There we go. And let's see. I'm just going to make sure I selected my whole object. So let me undo this and drag it back up. Because if you're just selecting the sphere, you're not actually selecting the box. So you want to select everything and then the food itself, and then you want to move that down. Okay, so let's say I drag that down. Notice this time the box is moving with me. So that is what we want. I'm going to put those objects just above the ground. Okay, now we can press play, and you'll notice I can just run straight through my food. So coming up next, we're going to set what we want to actually happen when we collide with the food. Hello everyone, and welcome back to our course. In the previous lecture, we created our food class and a visual for it as well. Coming up in this lecture, we're going to be able to handle collisions between the player and the food. And then later, we're going to spawn multiple food pieces all around the game at random. And we'll also have the player grow in size every time they eat a piece of food. All right, so for this, let's go back into our Visual Studio project. And we're going to create a collision box for our character controller, just like we did for our food. Because in order to be able to process collisions manually, we need to have a collision box for our objects. So let's go into the header file for our character controller, and let's declare a new property. This is going to be a U property, and we'll make it edit anywhere, which means we could edit it in Unreal even if we didn't compile this code. The type is going to be a U-shaped component pointer that we'll call the collision box. All right, next up, let's go ahead and actually initialize this value. We're going to do that inside of our C++ file in the constructor for our character controller. Here we're going to grab our collision box for that character, and we're going to use create default sub object. The type is going to be a UBox component, and we're going to have it be the root component. In order for us to be able to use UBox component, we do have to have at the top of our file the include for the UBox component, and it's exactly the same as what we use for the foods box component. So we'll just include that. Next up, let's declare a function that's going to handle the overlapping event. So we'll declare that inside of the character controller header file. Right, so here we're going to first specify the ufunction macro, and we'll call this onOverlap. This takes in a specific number of parameters. First, we need a U primitive component pointer called overlapped component. Next, we need the A actor pointer, and this is going to be the other actor. So we have the component that overlapped, and then the other actor, which is what the character collided with. Then we have a U primitive component again. So U primitive component pointer, and that is going to be to the other component, which is the component of the food. Next up, we then need our int32 for the other body index. This is just the convention for this overlap. Then we need a bool be from sweep true or false. A constant then that is going to be of type f hit result, which provides us with information about the collision. And we'll call this the sweep result. All right, so this is the declaration of that function. Then we can initialize it inside of our C++ file. So let's grab all the parameters. I'll copy them. Then inside of our C++ file, we are going to declare that onOverlap function with those same parameters. And we do have to specify that it comes from our aCharacterController class. Before we fill this in, let's also set that our collision box can overlap. It can process overlapping. So at the top of our file here in the constructor, we're going to grab our collision box and we're going to set its function for generating overlap events. So we'll call set generate overlap events and we'll pass in true, which means you can process overlapping collision boxes. Next, we have to enable dynamic collisions. So I'm going to grab my collision box again and grab here on component begin overlap dot add dynamic. So we can process dynamic collisions as the game continues to run. We're passing in this, which is the character that is part of the collision. And we're passing in the function that's going to process the collisions, which is going to be from our aCharacterController class, and it's the function we just built called onOverlap. This is the function that's going to handle dynamic collisions that happen throughout the game. So now we can go back to the implementation of onOverlap. And how do we handle overlapping? Well, all we have to do here is check what was the overlapped object, what did the character collide with, and then we can specify what we want to happen. So let's check if we have a food that we collided with, and if that happened, we want to destroy the food and grow the character. So I'm going to start with a check. We'll check if the other actor, which is what the character collided with, if that is A, and then we can pass in a class here. We're going to use a food. So if it's a food static class, that means we've collided with a food. Now, for us to be able to use the aFood class, we have to include it. Just because it's part of the package doesn't mean we can automatically include it. We do have to go to the top of our file and add an include here to food.h. Now we can put to use a food. Okay, so if the character collided with a food, we can just destroy that food to start. We'll call other actor and we'll call destroy, which is going to remove it from the game. All right, now we can go and test out our collisions. Oftentimes you'll find yourself having to change the actual collision type. You'll have to make sure the collisions are as well exactly over the object too. So let's go ahead and open up Unreal, and we can hit compile in the bottom right hand corner, and we can test out our collision. You'll notice now our character is going to have a box collision around it as soon as this code compiles, as long as it compiles successfully. If you have any errors, you have to go back to Visual Studio and press debug, and you'll get a detailed list of all the errors. But look at this. Now we can click on our character and press F, and let's just move over a bit so we can see it. We can see right here, we have this box around the player. Okay, so we can take this collision box object, which we just created via code, and we can move it around. So let's take its location and just perhaps change it to 1 to demonstrate. So if I change this to 1, that drags that over. If I change that to 1, it moves it over just a little bit. Let's make it a bit of a drastic shift. Let's say I change this to 5, then you can definitely see it moving. Okay, so let's set it to 1, 1, 1. We can also change the Z to be different as well. And we could change the scale. For example, 2 by 2 by 2, look at that. By changing the scale of my collision box, we can now see that it's a lot larger of a box around the player. So it depends on how easy you want the game to be. Because if you make this box larger, it'll be easier for collisions to happen. If you make it smaller, it'll be harder for collisions to happen. Okay, so let me just grab that, change it to 1.5, and you can do the same for your food. You can grab your food object, zoom in on that. You can change the collision box here if you want to make that smaller. You could change it to 0.5 by 0.5 by 0.5. Right, here we go. And if you want to keep the actual sphere regular size, you just increase the sphere. Then on the collision box, you can see the collision box remains small. Okay, so we have our food 111 now, but we have to adjust our collision box. Let's say we change the collision box scale to 1 by 1 by 1. There we go. Now it's a bit closer to the real deal. So there we have our sphere. Here's our food. We have the sphere. Then we have the collision box. And you can zoom in to see it. Okay, so now we can go ahead and press play. And you'll see if I touch the food, it actually disappears. Let me also just drop the food to the ground. So I'm going to use this arrow key. Let's see this. Sometimes it's hard to see the arrow key that moves down, but there we go. We'll drop that down. Then we'll press play again. There's that food. And look at that. When I touched the food, the collision was processed, so the food got destroyed. That is exactly what we wanted. Coming up next, we are going to increase the player's size when they eat a piece of food. And we're going to spawn our food dynamically. We're going to need a lot more food items. Feel free to also take your camera and move it up if you want as well a higher bird's eye view. So we'll just change the Z position there. For example, if you change it to 700, you can see we went a little bit higher up. If you change it to 1,000 instead of 100, if you change this to 1,000, there you go, you can see even more of the view. If I press play, now my player is a lot smaller, but the game works as per normal. Alright, so join me coming up in our next lecture. We're going to continue our project and we're going to dynamically spawn our food. So we'll have multiple pieces of food that spawn everywhere. Hello everyone and welcome back to our course. In this lecture, we're going to build a game mode that will dynamically spawn food in random locations around the world. So for that, let's go back into our Unreal project, and inside of our content browser, we're going to create a new C++ class. So here I'm going to add a new C++ class. You'll notice we already have a game mode, but this is the default game mode base, and we want to create our own. So I'll select add here and choose new C++ class. The parent class is going to be game mode base. A game mode is what controls the game, defines rules, spawns enemies, spawns food, and more. Press next and then give your game mode a name. For example, we could call this our top-down game mode. Then press create class, and that is going to launch your Visual Studio project. Make sure that the class is created inside of both your Visual Studio project and inside of Unreal before you continue further. So we can see it should be here. There we go. Top-down game mode has been created. And also in Unreal, we should go back to our project there, and we can see our C++ code is compiling. And the compilation is complete, and we can see we have our top-down game mode. All right, let's go back into our Visual Studio project. Here we go. And let's open up our game mode custom files. Starting with the header file. Here we're going to begin by creating our properties. All right, so we have just a generated body here. I am going to here create a public category. And first I can create a constructor. It's called a top-down game mode, the same name as the class. I can initialize the constructor inside of the C++ file. So here I'm going to grab a top-down game mode and just call that again for the constructor, a top-down game mode. Then make a call to super the parent constructor. Inside of the constructor, we're going to grab primary actor tick and set b can ever tick to true, which will allow the tick function to work. Without it, the tick function would not work. Then let's go back into our header file and create some properties here. starting with a property that represents our food. So I'm going to create a U property. It will be edit anywhere, which means we can set it in Unreal without compiling the code. The category is going to be our spawn category because this is for items that we're going to spawn. Next, we'll have T subclass of, and we're specifying the subclass that the property belongs to. It's going to be a subclass of the class A food, and it's going to be called our food blueprint. So we're going to turn our one food object into a reusable food blueprint. That way it'll be the blueprint for creating all of the food items. All right, and if we want this A food to work, it actually will already be able to be read because this is our game mode. All right, next up, we're going to need a property for our food timer. So let's call this a float called spawn timer. This will be how quickly we spawn something like a food or an enemy, and we could have multiple timers for how often we want to spawn different objects. Then we want to override the tick function because in the tick function is where we're going to spawn our food items. So I'm going to grab virtual void tick, which takes in delta time, and call override because we're overriding a pre-made function. Then let's go into our C++ file where we can implement the tick function. It's going to be a void function that comes from the class A top-down game mode. And it's called tick, and it must take in delta time. In this case, because we specified that as a parameter, you have to make a call to the super tick function because we are overriding a function. Okay, next we're going to put to use our spawn timer. We're going to take a spawn timer, which by default is 0, and subtract it by delta time. So we're reducing it a little bit every time the tick function runs, which is every frame of the game, usually 60 frames per second. Every time our spawn timer reaches a limit, that's when we'll spawn a new food item and we'll reset the timer. So let's say our spawn timer goes below 0. Okay, if it goes below 0, in that case, first we want to reset it. We want to reset it back to some value, such as our number of seconds between spawn. So let's create a new variable for this. It could also just be a variable of the class if you don't want to constantly recreate it in tick. And this is going to be a float. All right. Let's initialize this to equal some number of seconds, like let's say 1 second. That means we're going to be generating a new food item every second. So how do we actually generate the food item? Well, first we have to get the current world, and then we can spawn an actor in that world. So let's make a reference to, or pointer specifically, to our world by grabbing the function getWorld. Then we'll check if world is true because we don't want to be spawning actors if a world doesn't exist. In order to spawn an actor, you need the blueprint for the actor, you need the location for the actor, as well as a rotation, and you can add any extra spawning information you'd like. Let's start with location. So I'm going to grab an F vector here. I'll call this my food location. And I could set this to just a new F vector and pass in here any location I want, but I want to use a random location. So I'm going to build for us a helper function called generateRandomLocation. Okay, then let's define that function inside of this C++ file. All right, so we're initializing it here. It's going to return an F vector, we already know that. And it comes from the class A top-down game mode, and it's called generateRandomLocation. Let's also define it inside of the header file. So we're going to grab here. It returns an F vector. It's called generateRandomLocation, and it doesn't override any previous function. So how do we generate a random location? Well, first let's create an f vector that's called location. Then we're going to grab location and set one of its properties like the x position, because an f vector has to specify the position on all three axes. Otherwise, by default, it will just have the value 0 for that axis. Then we're going to use the math library, and we're going to use the rand range function, short for random range. Here we can pass in a minimum and a maximum number for our position on that axis. They have to be floats. So let's start with minimum. We can use 100 as our minimum. Then maximum, let's use 1,000 as our maximum. And we could adjust this if we wanted to spawn our food closer or farther away. You could also spawn food around the player by using the player's location. Let's do the exact same thing for the Y position. Now for the Z position, that's up and down, so we want to actually keep that fixed. Let's set location.z to equal 0. Otherwise, our food will be spawning in the air, and we don't want that. Finally, this function is going to just return that location. Okay, so now we have generated a random location, and we can already generate a food item. So what I'm going to do, I'm going to use my class A food, and I'm going to create a pointer here. I'll call this food. And that is going to be the result of my world calling the function spawn actor. Here we'll pass in the type, which is a food. Then we'll pass in the parameters. Okay, starting with the blueprint, which is the food blueprint, which we'll have to fill in via Unreal. Next, we need the location. It's going to be the food location. Followed by the rotation, we'll just do 0 rotation, so f rotator 0 rotator. And we can also add extra information if needed, such as if we should spawn even if we're overlapping with something else, and more. All right, so let's go ahead and compile this on the Unreal side. So I'm going to go to Unreal, and I'm going to press compile. Before we'll actually see this in action, we have to specify a few things. First, we have to specify what is that food blueprint. So we have to make a food blueprint. And as well, we have to change the world settings in our game. The world settings have their own game mode that we have to change to our game mode. You'll notice here our compile failed. So let's just see what's the issue here. Going to go back into Visual Studio because Unreal doesn't give the best explanations for issues. So instead I'm just going to press debug on the Visual Studio side, because you can see my explanations are a lot more detailed. Okay, let's see. The problem is that we didn't specify what is a food here in our game mode. Yeah, okay, so our game mode needs to use a food. I'm going to go to the top here and I'm going to include my food.h. Okay, now we can go back into Unreal and we can press compile. Great, and the compilation completed. So join me in our next lecture where we're going to connect our code that we just wrote and change the settings in Unreal so that that code actually works. Hello everyone, and welcome back to our course. In the previous lecture, we learned how to write the code to dynamically spawn food. But if we want this to actually work in our Unreal project, we have to change some of the settings in our project. So join me back in Unreal and we'll get started. First, we need to create a new blueprint class with our game mode as the parent. So inside of our content browser, let's go into our content folder, which contains the folders of our project other than the C++ classes. Here I'm going to create a new blueprints folder. So I'm going to add here a new folder, and I'll call this blueprints. Then inside of the blueprints folder, I'm going to add a new blueprint class. And I'm going to select my custom game mode that we built as our parent class, not a game mode base. So here I'm going to search for game mode, and we had our top-down game mode. This is what we built, our C++ file. Right, then I'm going to hit enter, and that's going to create that blueprint. I'm going to call this BP underscore game mode. All right, so now we have a blueprint to represent our game mode. And let's double click on that in order to open it. So the reason we needed to create a game mode blueprint is to set the property here for the spawning. You'll recall that on the C++ side, we created this food blueprint U property, and we put it under the spawn category. And here it is right there. You'll notice its value is none, but in order for a food to be able to spawn, we have to specify the food blueprint. So let's go into our level and let's create a blueprint for our food. So currently in our world outliner, we can see food 1. This is just an object that we created. We dragged our food C++ class into the viewport, and then we gave it a sphere. But I want to turn this into a blueprint. So I'm going to go into the details window, and here I'm going to use the icon in the top right hand corner that looks like a little blueprint diagram. This will convert the actor into a reusable blueprint class, which means I'm just taking this object and making it reusable. So I'm going to click that. My parent should be food, and we can just call this our food underscore blueprint. That's fine, and press select. Now we can see our food and its collision box as a blueprint, and here we can actually adjust this. We can drag down that sphere, so that way the sphere is inside of the collision box. Okay, then let's save and compile this, and now we have a reusable food object. We can drag up that one food item. Inside of our world outliner, we can see our food 1 has changed to become food blueprint, and this is now reusable. So I could drag the food blueprint into the game as many times as I want, and each one is its own food item. So if I press play, let's go ahead and launch this. Look at that, we have 3 food items, and I can run around and I can eat each of them individually, so they act independently of each other. Next up, not only do we have to set the food blueprint, but inside of my game mode, I'm also going to set the default pawn class to be, instead of the default pawn, I want it to be my character controller, which is that C++ class that we created together to represent our player. Okay, and on top of that, we also have to change the game mode used by our world, because there's a default one, but we want to change it to be our blueprint now. And pay careful attention, it has to be your blueprint, not your C++ class, because the blueprint is the one that has this food blueprint, which by the way, we now need to change to have a value. So make sure in your game mode food blueprint property, you actually put in what is the blueprint used to create new food items. Then let's go to our project settings, and I'm going to go into our game mode. Okay, so I'm going to search here for game mode, and I'm going to change the default game mode from game mode base to instead my blueprint underscore game mode. That's the one that's an instance of my custom top-down game mode C++ class, and it's a blueprint because it has that property filled in for its food blueprint and its new default pawn. You should see here under selected game mode, your default pawn class should be character controller because we changed it to character controller. All right, and that is all we need in order to enable multiple food items to be spawned. So now let's go ahead and open up our world outliner so we can see new objects as they're spawned. And look at this, we can see new objects, new food items are being spawned around the world. Each food item is spawned every 1 second, and I can run around and I can take a look. There they are, and if I eat one, the other ones don't get affected. Each food item here is independent. So here they are being spawned. You can spawn them faster, slower, and in larger areas if you'd like. You can customize the spawning however you need for your game. The point is that we got the base functionality down. We're prototyping the game with this basic functionality. So there's all the food and we can eat them up. Awesome, and that is how we can enable our code that we wrote in C++ to actually work in the Unreal project. So we had to write the C++ code and then make some adjustments. All right, join me coming up in our next lecture. We're going to continue our project, building out our game, and we're now going to change the player's size and their speed whenever they eat a food. Because currently, if I eat a food, nothing really happens, just gives me the satisfaction of making them disappear. But coming up next, we're going to slow down the player whenever they touch a food item, and we're also going to increase their size. Now, you could have any change in the player or in the world that you want. You could have the score increase, you could have the health increase, whatever you'd like. We're going to start with some basic functionality of making the player change size and change speed, and then you can adapt that to have any kind of change to the player that you'd like when they eat a food. So I will see you coming up in the next lecture.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only will you get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy before the sale ends. Thanks for watching, and I'll see you in another video.